basic questions on pressure, and these may help to clear all the confusions that you may have and also give you an overall idea on what the chapter is about. The diagram shows a manometer containing mercury that is still at one end. What happens to the distance h when the manometer is taken higher up a mountain? So, at a higher mountain, the altitude is very high, which means that the air pressure is very low. And so the correct answer should be option A, meaning that the distance decreases because the atmospheric pressure decreases with the height. 5 blocks have the same mass but different base areas. They all rest on a horizontal table. A graph is plotted to show the relationship between the pressure exerted on the table and the base area of the block. Which graph shows this relationship? We already know that pressure decreases when area increases and increases when area decreases. So the only correct answer we are left with is option D, which shows that pressure is inversely proportional to area. Some doctors measure blood pressure by using a mercury manometer. Blood pressure varies by 5.6 kilopascals as a heart beats. The density of mercury is 14,000 kg per meter cube, and the gravitational field strength is 10 newton per kilogram. What is the change in the height difference between the levels in the manometer during a heartbeat? So if we follow the formula where pressure equals to H rho G, we can simply make H the subject, which will equal to the pressure divided by the product of rho and G. And we can write 5.6 kilopascals to 5600 pascals and then divide it with 140,000, which will give us 0.04 meter. The options here are in millimeters, so we are just going to change the unit to millimeter, and that gives us 40 millimeter, which is our answer. Mercury is a liquid. The diagram shows a simple mercury barometer, which height is a measure of the atmospheric pressure. It is a general rule that the height of the mercury liquid column is the only height giving us the atmospheric pressure from the barometer. And so our answer should be none other than option C. Two vessels S and T are filled to the same level with the same liquid. The area of the base of S is less than that of T. Which statement is correct? Option A states that the force on the base of S is greater than the force on the base of T, which is wrong because we can see that the mass in T is greater than the mass of S, meaning that the force acting on the depth of or on the base of T is greater than the force acting on the base of S. And then we have option B, which states that the force on the base of S is the same as the force on the base of T, which is wrong. Option C says that the pressure on the base of S is greater than the pressure on the base of T, which is wrong because the pressure caused by a liquid column depends only upon the height, or you can call it the depth of the liquid column, and also the density of the liquid column. And since we know that they are in the same height and they both have the same liquid, meaning their density is also equal. And so it will say that it indicates that both S and T creates the same pressure, which takes us to option D, our correct answer. The diagram shows two identical pieces of apparatus. One is filled with water and the other is filled with mercury. Water is less dense than mercury. At which point is the liquid pressure greatest? We already know that water is less dense than mercury, which increases the pressure created compared to mercury, and this also automatically crosses out the two options A and B. Once more, if we recall the formula, P is equal to H rho G. Since the density is equal as both D and C have the same liquid, it only leaves us with the depth, and our correct answer is D, as it has a greater depth than option C. That's the end of today's video. Hope you'll like it and stay tuned for the upcoming videos, and don't forget to share your thoughts in the comments below. Bye bye.